Let's consider another example. Load content of memory location 8500 directly to accumulator and transfer it to register B. This is what the same program we have done in a different manner. A800 onwards I am writing the program. LDA 8500 is a 3-byte instruction. So 00, 01, 02 will be used for completing this instruction. In A800 LDA will be written. In A801 00 will be written. In A802 85 will be written. In A803 I will have this instruction move B, A, and in A804 I will have this instruction halt. So upon execution of this instruction, load accumulator direct the content of memory location 8500. 8500 has a content 05 that will be loaded to the accumulator register. So the accumulator register now will have a content that is 05. Next instruction is move B, A. Copy this content from accumulator register to register B. Then this value 05 will be copied from accumulator to register B, so that both these registers will now have this number 05. Then you can halt. But I have already told you this will be consuming one additional memory for the same program comparing with this one, or for the same activity comparing with this one, and it consumes 6 more T states comparing with this one. Now consider another program. Move the content of the memory location 8500 to register C. So 8500 once again has a content, say for example 05. We have to move this content from 8500 to register C. That can be done by using the former program as well. You can take this number directly to accumulator, then using the instruction move C, A, the number could be copied to C register. But I am going to write it in a different manner. Let me start the program from A800 onwards, where I write the instruction LXIH8500. This asks the processor to load the HL pair by means of this address 8500. So HL pair now will have a loaded value of content which is 8500. That is the memory location where we have this number, and we have to perform an activity with this number. Now I am going to write this instruction move C, M, where M stands for the memory location pointed by HL pair. So upon executing this instruction move C, M, content of the memory location pointed by HL pair will be copied to register C. Then content of C register becomes move C, M, content of memory location pointed by HL pair. HL pair now has a content 8500. That's the address of a memory location. Content of this memory location is what is being labeled as a capital M. That happens to be say 05. So this copy 05 from this memory location to the register C. So C register will now have a content say 05. This is being asked to perform. Now you look at this program, number of T states and the number of memory locations being consumed for this program. LXIH8500 is a 3-byte instruction. So this will consume A800, 01 and 02. In 03 we have written move C, M. In 04 we can halt the program. Overall it consumes 5 different memory locations and the T states involved. LXIH8500 is a 3-byte instruction. that involve memory and opcode fetch machine cycle, memory read, and then one more memory read. Overall 7 T states will be there. No, 10 T states will be there because there is one opcode fetch and 2 memory read. Move C, M is a 1 byte instruction. There will be only opcode fetch, and for halt a total of 5 different T states will be there. 14 5 19 T state ആണ് ഇതിന് വേണ്ടി വരുന്നത്. So you can perform the same activity using this kind of a program as well. MVIC content of this memory location, once it is known as 05, we can write MVIC 05. But specifically you are being asked to load the content of this memory location 8500. That can be any particular value. So specifically this kind of a program needed to be taken into consideration comparing with this first program. But the second program can be incorporated for this one. You can write LDA 8500 move C, M. That is possible. Move C, A. That is possible. But this has an ease. Suppose you have to further load another register B with the content of the memory location 8501. Then I just have to increment the content of HL pair by 1 so that new content of the memory pointed by HL pair becomes content of 8501, and that can be copied to or moved to register B as per our requirement. So besides considering the minimum number of memory location being used and the minimum T states being used, we will have to consider the practicality of the program as well, or the possible ease of the instruction that may bring to the programming scenario. Now let's consider another program. Now let's consider this program. The question is, place the content of the memory location 8500 in register B and that of 8501 to register C. So we have two consecutive memory locations. In this case, say 8500 and 8501. The content of these memory locations can be anything because you have methods of accessing these memory locations directly and feeding numbers to these locations. Let 8500 has a number say X, or say let's take it say 78, and 8501 has another number say 82. You are asked to copy this number 78 to register B and this number 82 to register C. For that you can write a program like this: LDA 8500 move B, A. This asks the processor to load the accumulator directly content of this memory location 8500. That is 78. So 78 will be there in accumulator now. So the accumulator will have now this content say 78. Move B, A. Copy the content of accumulator to register B. So 78 is copied to register B. Now the second activity to be performed is move the content of 8501 to register C. And further you will have to load the accumulator with this content of 8501, LDA 8501. So the accumulator is now loaded with the content of the memory location whose address is 8501, which is 82. So the accumulator now will have a content 82. Now copy these to register C. Move C, A. Content of accumulator will be copied to register C, that is 82 is copied to register C, and you can halt the program. Let me write this from A800 onwards, then A800, 01, 02, 03, 04, 05, 06, 07, 08. I will end the program at the memory location with address A808. Overall, there will be then 9 memory locations being consumed. And T states also you can count. LDA 8500 ക്ക് 4373 10 T state, 14 10 24 4 28 5 33 T state ആണ് ഈ ഒരു പ്രോഗ്രാമിന് ടോട്ടൽ എടുക്കുന്നത്. Now we do the same in a different manner. LXIH 8500 load the HL pair directly content of memory location, not content but the address 8500. So now HL pair is loaded with the address 8500. The content of this memory location pointed by HL pair is referred to as memory. A memory now will have a content that is content of 8500 which is 78. Next instruction is move B, M. Move the content of the memory location pointed by HL pair to the register B. So content of register now becomes content of the memory location pointed by HL pair, that is 78. Next instruction in this is INXH. Increment the content of HL pair by 1. HL pair now has a content 8500. That is incremented by 1. Then this becomes 8501. Then the content of this memory is 8501 has a content 82. Then memory now has a content that is 82. Next instruction is move C, M. Move the content of the memory location pointed by HL pair to the register C. That is 82 is copied to the register C. C register will now have a content 82. Now you can halt the program. And we begin from A800, A800, 01, 02, 03, 04, 05, 06. The program will be wound up at the memory location with address A806. Overall, 7 memory locations are being used, whereas this has used 9 consecutive memory locations. So it offers you 2 lesser number of memory consumption. Now the T states. This has opcode fetch, memory read, overall 10 T state. Move B, M will have 4 T state. INXH will have 4 T state. Move C, M has 4 T state. Halt has 5 T state. 3, 4, 12, 10, 22, 5, 27. The T state consumption also is much lesser than this program. So this is a good piece of program. Now this has the scope of adding 2 numbers as well. Suppose you are asked to perform the addition of 2 numbers. One of the number or the first number you have to feed, or you may be feeding in the memory location 8500. The second number you can feed it to 8501. Then you have to add these 2 numbers. For that, you take one of the number in accumulator, the other one in a register, say B or C or whatever may it be, any one out of the 6 general purpose registers. Then adding these 2 numbers. That's all. Such a program we do here. Addition of 2 8-bit numbers. So you have 2 numbers. You are asked to add these 2 numbers. We assume that the result is also 8-bit, but there is the scope for the result which is more than 8-bit or say 16-bit. We will do such a program shortly. For the time being, the result is 8-bit. So we assume that we have the first number in the memory location 8500. The second number in the memory location with address 8501. ഇനി ഇത് രണ്ടും ആഡ് ചെയ്യാൻ ആഡ് എന്ന ഒരു ഇൻസ്ട്രക്ഷൻ യൂസ് ചെയ്യേണ്ടി വരും എന്തായാലും. ഇതൊരു അരിത്മെറ്റിക് ഇൻസ്ട്രക്ഷൻ ആണ്. എല്ലാ അരിത്മെറ്റിക് ഇൻസ്ട്രക്ഷനും ഒരു പ്രത്യേകത ഉണ്ട്. ഒരു ഓപ്പറന്റ് നിർബന്ധമായും അക്യുമുലേറ്ററിൽ ഉണ്ടായിരിക്കണം എന്നുള്ളതാണ്. അപ്പോൾ ഫസ്റ്റ് നമ്പറിനെ നമ്മൾ അക്യുമുലേറ്ററിലേക്ക് എത്തിക്കുന്നു. സെക്കൻഡ് നമ്പറിനെ മെമ്മറിയിൽ വെച്ചിട്ടോ അല്ലെങ്കിൽ ഒരു രജിസ്റ്ററിൽ വെച്ചിട്ടോ ഒക്കെ ആഡ് ചെയ്താൽ മതിയാകും. ഫോർ ദാറ്റ് we load the HL pair by means of this address 8500 using the instruction LXI